Hello, good afternoon, good evening, all. Good morning. This is Guillaume Calfon. I'm moderating here a new session of Lubrication and Reliability Virtual Summit. This is my fourth today as a moderator. I am very fortunate that it's a very diverse set of topics and all of them crucial. So it's very enjoyable and a lot of learning. So this session is not about me, of course, by Harshadkumar Pandit, who is Manager Technology at Hindalco Industries. So we have Harshadkumar with us here. I don't know if Harshad can say a word, say hello. Obviously, he's in transit in a vehicle right now, so we will carry on. His presentation is about to go ahead in a few moments, but of course, don't forget, we are here to work, we are here a little bit also to play to win. So for this session, there is a code for play to win for wonderful prizes. So the code is now on screen. I leave you a few seconds so that you can memorize it to take part in the game. Okay, everybody. Very good. So we will now listen to Harshadkumar's presentation. Your questions in the chat function. Any question you have, don't be shy, and we will attend to the questions after the end of this presentation. Happy listening, happy learning.
Hello everybody, welcome to Lubrication and Reliability Summit 2021. First of all, I would like to thank LRVS management for giving me an opportunity to present my paper here on this particular platform. So today I'm going to present a paper on regeneration of rolling oil from waste fuller earth under sustainability category. So before we start, let me introduce myself. I am Harshadkumar Pandit. I am a technocrat and certified lubrication engineer by STLE. I have done my graduation in oil solid chemicals and surfactants and MBA in R&D. Currently, I am working at Hindalco Industries Limited, which is an ABG flagship company, and I am part of R&D team and works on development of oils and lubricants for internal consumption. So let's start with this paper. So in this paper, I'm going to take you through aluminium and aluminium rolling lubrication, rolling lubricant and its sustainable use. What is waste fuller earth? What is the process for oil recovery, what we have developed. Then we will see effect of extraction additive on various aspects like oil recovery, its quality, the quality of fuller earth and its characteristics. And finally, we will look into the conclusion. So let's start with the paper. As all of you know, the use of aluminum has increased in many various applications over time. It is second highest metal used after steel. Aluminum finds more than 3,000 applications in various industry. It offers very good tensile strength, castability, formability, good chemical resistance, and various surface treatment processes. It has very good electrical and thermal conductivity. Along with that, aluminum is lightweight and it can be recycled infinitely. So that's make it the metal of choice for various applications. Few of the applications are like transportation, structural components, packaging, electronics, and machine components. Aluminum is used in various forms like casted material or extruded profiles or flat roll products. Flat roll products contributes approximately 50% of aluminum consumption in the industry, and hence it is very important. In the last slide, we have seen the aluminum consumption in flat rolled product form is more than 50%, and it makes a very important aspect when it comes to aluminum manufacturing. And if you see, lubrication is an integral part of flat rolled product segment. FRP manufacturing can be categorized in hot rolling, first where ingot is rolled into aluminum sheet of particular thickness. Then this particular sheet is further rolled in cold rolling mill to reduce the thickness, and for the applications like foil or pharmaceutical industry, it is further rolled in rolling mills, which is known as foil rolling mills. Each of these processes uses various different lubricant in the rolling process. Hot rolling process uses oil in water emulsion as a lubricant, while cold rolling and foil rolling processes uses mineral oil along with fatty additives as a lubricant. In all these processes, lubricant used in the mills undergoes filtration continuously. This is to remove the debris and aluminum fine generated during rolling applications. In hot rolling mill, the filtration happens only to filter media, which is nothing but polypropylene or polyester paper through which the emulsion is passing. Whereas in case of foil mill or cold mill, filtration happens through multi-stack plate filtration unit. So here on filter media of polypropylene or polyester, the mixture of diatomaceous earth and fuller earth is used as a bed, and through which the filtration happens. So once the DEFE bed gets exhausted, it is discarded and new bed of DEFE is made on the horizontal plate filter for cold mill and foil mill filtrations. In earlier slide, we have seen the process of manufacturing flat rolled products of aluminium. So here in this slide, we will look into rolling lubricant and its sustainable use in rolling mills. If we see the cold rolling mill or foil rolling mill, there are majorly two reasons because of oil is getting lost. One is evaporation loss, and second one is oil carryover. Evaporation loss is reduced by putting oil recovery units at the exhaust, and oil carryover is controlled by air knives and appropriate mechanisms at mill. Now, when it comes to heavier oil leakages, the oil reservoirs get contaminated, and which needs to be controlled by leak detection dyes in heavier oils. Now, contaminated oil is recycled back by doing vacuum evaporation, and heavier oils are removed from that, and some oil loss happens in vacuum distillation. Now, when it comes to horizontal plate filter, the oil is lost with wasteful earth. The wasteful earth contains 35 to 40% of rolling oil, and currently there is no process by which this oil can be recovered. On small single stand cold mill, 35 to 40 metric ton of wasteful earth is generated, which results into 10 metric ton of oil loss. And if you consider in terms of money, the average loss is 25 to 30,000 US dollar per annum. So to solve this problem, we have developed oil recovery process from waste fuel earth, and in this paper we will see the process of oil recovery from waste fuel earth for sustainable use of this particular lubricant. So in this slide, let's see the composition of waste fuel earth, which is generated at horizontal plate filter in cold mills or foil mills. As we have already seen, it contains 35 to 40% of rolling lubricant in it. It contains 40 to 45% of diatomaceous earth, 25 to 30% of fuller earth, and less than 1% aluminum fines and debris. Now let's see the process of oil recovery from waste fuller earth, which we have developed in-house. So let's see oil recovery process which we have developed in-house. In step one, we mix waste fuller earth, water and proprietary acidic additive together. The mixture is heated to 80 degrees Celsius for 1 hour, and then it is cooled down to room temperature. In step two, the oil which is been recovered and floating on water is extracted or removed, and the remaining mixture is passed through filter press. The acidic water from filter press is used again in step number one. In step three, the recovered oil from step two is first pre-treated and then vacuum distilled, and fuller earth, which is recovered in filter press, is dried and regenerated at 775 degrees Celsius for reuse. Now let's see the effect of acidic proprietary additive on oil recovery process. If you see the graph, it is clear that 80% of oil is getting recovered with 5% of proprietary additive. Further increase in concentration of acidic additive marginally improves the oil recovery, and maximum 82% of oil can be recovered by this process. Now let's see the effect of proprietary additive on oil quality. If you see this picture, as we increase the concentration of additive, the color of oil is getting improved. It also helps in reducing the moisture content of recovered oil. In the next slide, we will see. Now let's see the typical characteristic of recovered rolling oil. If you see the FTIR peak at 1715 is present in recovered oil, while same is not present in rolling lubricant which is used in system. This indicates that there is a conversion or splitting of fatty alcohol to fatty acid in this treatment, which is getting removed in pre-treatment and vacuum distillation process. If we compare the carbon chain distribution of fresh rolling oil against recovered one, there is no drastic difference. Taking GC as a basis, recovered rolling oil is suitable for application in rolling mill again. Now let's see the effect of proprietary additive on recovered fuller earth. As we increase the concentration of additive, the color of fuller earth improves. Waste fuller earth contains approximately 30%, 35% to 40% of oil in it, and that's why it has calorific value of 2800. But when we extract the oil from waste fuller earth, calorific value reduces to 400 plus minus 20 calories per gram. With recovered oil, we can do two things. One, discard as it is as a non-hazardous waste, and second, retreat or regenerate the waste fuller earth at 775 degrees Celsius and reuse in the system. Now let's see the composition of recovered and regenerated fuller earth. If you see the picture, you will see there is a good porosity in retreated waste fuller earth. If you see the composition, elements like magnesium and calcium are not present in retreated filter earth. This is because these elements are forming salt with additive and getting removed in water. But overall composition, if you see, there is no major difference, and that's the reason we can reuse the regenerated fuller earth back in the filtration units. Now let's see the filterability of retreated fuller earth. If you see the table, the waste fuller earth which is retreated and regenerated has a flow rate of 0.052 as against 0.027 of fresh one. This is because opening of pores in diatomaceous earth by the treatment. Now let's see the conclusion of the paper. From this study, we can conclude that cold rolling lubricant can be effectively recovered. Up to 80% of rolling oil recovery can be achieved with 5% of proprietary additive concentration. The quality of rolling lubricant is appropriate for its reuse. The waste cake, which is regenerated, can also be reused for filtration. Regenerated cake has better porosity and similar composition, and hence it can be reused again in filtration unit. That's all from my side, guys. Thank you for listening me. You can contact me on given email ID for more information. Thank you.
सर देख लीजिए आप
Hello, Harshadkumar. Hello, thank you very much for this
আপনার
presentation.
ক্ষেত্রে ওরকমও হতে পারে যেগুলো বলে দেবে যদি কেউ
Thank you, Josh.
Hey, I'm actually Guillaume. We have only one ID for all the moderators, but that's why you see Josh. In any case, thank you very much for this presentation. It's very much focused on sustainability and circular economy. These are topics that are rising very fast. So it's essential to understand how we can recover materials, in your case, the rolling oil and the fuller's earth. Both. It's very captivating to see and understand the details of how you're able to do that. We have at the moment any questions from the attendants, so let's give them a few more minutes to see if anybody feels like asking a question. For your company at Hindalco, how much rolling oil do you think you're able to save or to recover, say, for instance, in 1 year in rolling oil?
See, Josh, I mean, at Hindalco, we are having various rolling mills, and the amount of rolling oil which we will be recovering by this process will be huge. I mean, it would be like thousands of tons of oil we will be able to recover with this process. Currently, which goes as a waste, I mean, it goes for incineration. So we do recover energy out of that, but as a fuel, I mean, it's very expensive if you see.
Yes, it's not the best value because these rolling oils are pretty expensive formulations on them.
Exactly.
To give context, Hindalco is the leader of aluminium rolling, or one of the leaders.
Yeah, so Hindalco is the Aditya Birla Group company, and as you know, I mean, we took over Novelis in 2009, and recently you must be heard of acquisition of LRVS. So Hindalco is the flat rolling producing company in the world right now.
Okay, all right. And your production includes the smelters, and then downstream of the smelters, you do the flat rolling.
Yes. So in Indian operations, we do have smelters with captive power plants, and as far as Novelis is concerned, the overall manufacturing is linked to recycling of aluminium. I mean, recycling of beverage cans, and then making the aluminium sheet out of that.
Okay, I understand. We still don't have any questions, but I'm happy to come up with my questions. So apart from the rolling oils, do you see other big opportunities to recover oils or recondition them, or
so a couple of so a couple of projects currently on which I'm working is, one of them is because we do have power plants with us, and
idea to the service life of this. So this is one of them. And other than that, apart from neat oils, I mean, we are also working on recovering the emulsions, because emulsion is very big part of rolling lubricant as such when it comes to hot rolling. And currently this particular lubricant and processing is very gray area, I mean, from sustainability point of view. So we are actually working on recovery this particular oil.
Yeah, so the presentation that you just gave was regarding neat rolling oils. And you believe you could also recover or save some of the emulsion oils in rolling, in hot rolling.
Yes.
We are seeing some questions now. A question. I don't know if it comes on your phone screen. Why don't we use resin-based filters in place of full earth for regenerating of for regeneration? Resin is very easy to use compared to. What are your thoughts?
Yeah. So resins are, I mean, used normally to what you called absorb the contaminants of ionic forms. I mean, events like plus plus or minus minus get actually absorbed on these resins. Works in that line, whereas in the aluminium industry, the fuller earths what we are using right now, they mostly capture the aluminium fines and aluminium oxides. These are not particularly ions. So I'm very doubtful on the aspect what Yogesh has written. I mean, use of resins for filtration purpose. So that I mean needs to be checked. I mean that's really, I mean, interesting aspect what Yogesh actually brought on the table. I really need to check on that particular aspect, if resins are really useful in recovering the aluminium fines and oxides from rolling oil. And if it's possible, then as Yogesh said, I mean, it's very easy to recover the fines or waste oil from resins. Exactly.
Okay, thank you, Yogesh. Thank you, Harshadkumar. So regarding the acidic additives that you use, can you hear me? We have another voice. Yeah. Regarding the acidic additives that you use for the purpose of recovering oil, fuller's earth, can you re-explain?
It's like sulfuric, nitric, and yeah, I'll tell you. Yeah. So this is a mixture of nitric, sulfuric, and it's basically acids actually acts with aluminium fines and converted into soluble salts. I mean, and that way it actually opens the pores of diatomaceous earth.
Thank you. Okay, thank you.
Yeah.
Oh, we don't have any other question coming for the moment so far. Harshadkumar, would you take this extra time that we have to add anything that is on your mind with what we have already discussed?
No, as such, I think I would like to thank LRVS for giving us an opportunity to present this particular paper here on this particular platform. And I'm really sorry, actually, I am actually traveling, and hope you are actually hearing.
It's pretty good. We just lost Harshadkumar, but we were able to answer to hear his. Hello, Harshadkumar. Just a sec. Give me a second.
Well, I'm actually switching off my camera because of the connectivity issue.
Yes.
But am I? Yeah.
We hear you. We hear you well. You have a good connection.
Yeah.
We had lost you for 1 second, but we hear you well. Is there anything you wish to add, as we haven't had questions, so you have a chance to develop a bit more? Any aspects or any points that you wish? You still have a few minutes.
Used in aluminum or other look into overall recyclability point of view needs to be relooked actually. So currently the scenario is once you the lubricant goes for either disposition or as a source of energy. I mean users or really need to look this recyclability of the point very clearly. So that's my on this particular thing.
Okay, thank you. And definitely, this is something we see very much, and we believe in very much. That there's a lot of opportunities to get a way longer life. Lube oils, hydraulic fluids. It's to be a main next for this industry to be able to use this much longer between changes. Okay, Harshadkumar, I think we'll end the session now. Let you travel in comfort. Stay safe. Thank you very much for your presentation. And we will say goodbye, talk on another occasion.
Thank you, Josh, and thank you, listeners. Thank you.
Thank you, goodbye.